Thanks a lot. This is a nice mic test. You can shout and do the mic testing. So hello, everyone. How's everyone doing? Make some noise. It's the last talk, and after that, you get to a party. Yeah, so how many React developers here? A lot. Nice. And how many of you have worked with React 18? Not so much. OK. So today, I'm going to be talking about the performance wins, which you can get using React 18. I will be focusing on rendering performance, concurrent rendering, or concurrency. Then we talk about transitions, automatic batching, suspense, and React Server components. So we will be going through each of these sections one by one. My name is Aashima. I'm working as a senior front-end engineer at FareHarbor. 2 months back, I was working in Meta, but I recently joined FareHarbor. I'm originally from India, coming from Amsterdam. If you have any questions after the talk, feel free to connect me over LinkedIn or just bump me up anywhere. So talking about rendering performance. So first, let's see what is rendering. So rendering is when browser paints a bunch of stuff on the screen to display it to the user. So usually, there are 2 stages of rendering. One is when component appears on the screen for the first time. And this is what we call initial render. And the second one is when the component is already there on the screen and user interacts with it. So browser has to re-render it to show the updated result to the user. So this is called re-render. Now, whenever React has to show any visual update, it creates a virtual DOM. So in virtual DOM, React will do all the changes related to state. And this happens in the render stage. Now, this render phase is very important, because in this phase, React builds the virtual DOM, makes changes to the virtual DOM, computing the changes, what has changed from the original DOM. And this is where all the calculations are happening. So it prepares those necessary updates. And finally, React will enter the commit phase, where it commits all the changes in the virtual DOM to the actual DOM. And then user sees all those changes. So why I'm telling you this? Everyone knows, OK, this happens. But this is a very important phase, because in rendering, it will depend on how complex the components are. If the components are taking long time, the render phase can also take more time to complete. And then there's like scope of improvement. So for the very complex components, the rendering can be really slow. And it's not very difficult to achieve. So we can see in this example, we have an input box where we would just type and filter the list of items. And we have like a very long list of items, so it's like 2,000, 5,000 items. So in order to code in React, we would have to take like 2 states. One is the query, another one is the filtered items. So the query will store all the results, which will store the state when user is typing in the input. And the filter results will have the filtered list of results. So now we need to, on the input change, we want to call a function, which is filter items. In the filter items function, it's going through the, it's checking what user has typed in the input, and then filtering based on the typed value. And then we set the 2 states, set query and set filtered items. So now if I try to execute this, make sure you pay attention to the input box. So when I'm typing, like there is a bit of lag, but you will notice more as I press back. So you see, I have pressed back. My hands are up. It took a while to render the search. And both of these search box, as well as the list of items, got updated together. I will do it once again. Sometimes you really want your computer to be slow, but it is not right now. But yeah. OK, see? The input is not cleared, and then results appear at the same time, and the input gets cleared at the same time. So if I ship an experience like that, so now, sorry, we filtered the items and displayed the list of items. And if we check on the performance tab, you see a lot of red things. So you see how bad the performance is, because on each keystroke, there is a long task which is getting executed, because the list of filtered items is really long, and it is taking long time. So now if I ship a feature like that, my boss would either kill me or cut my bonus for sure. So we need to improve it, right? But first, let's understand why this is happening. So as I mentioned, there are two state updates which were happening. One is the input, another one is the filtered items, right? We set the query, we set the filtered items. Now this filtered items state is a slower update because React takes time to render such a big list of items. So because of this, and React being React, it will do everything together. So both the state updates are going to happen once. So React will wait for filtered item state to get updated before it can make those changes to the DOM. So here the problem lies. So this is what is traditional rendering. So this is what is happening traditionally in React before React 18. Everything is synchronous. There is no way to tell which state update is important, no way to prioritize, interrupt the renderer, or even stop rendering. It is either all or none. So that's where we come to concurrent rendering. And this was the breaking change in this version. So concurrent rendering says that it will expose some of the methods in which you can tell that which state update is a important update and which one is a non-urgent update so that it can take like less priority. So what happens is that the high priority updates, they get instantly committed to the main thread and shown to the user all the changes. The low priority updates, they are happening in the background, and it's not instantly committed. So while React prepares the low priority updates in the background, it will go to the main thread, always check if there is anything more urgent, so that it can prioritize that. If there is nothing, like main thread is completely free, React will prepare and ship and commit the low priority updates to the main thread and to the DOM. So the good part is that now we can tell which is our important update, and we can React will pause and interrupt the render. So like in the input box example, which was the important update, React could instantly commit that to the DOM without waiting for the filtered items to get updated. But usually, all these things we don't have to care as a developers, how concurrency is working, what changed, what not changed. All we care about is how we can leverage those features to improve performance of our application. And this is where transitions come. So React has a couple of APIs exposed by which we can leverage the concurrency. So these are the two hooks by which we can use the concurrent features of React. One is useTransition and useDeferred value. I will go through the same example, filtering the large list of items. So now here, in order to use useTransition, we need to first import useTransition. useTransition returns us two things. One is pending flag, and another one is start transition. Now, which one is my slower update? It's set filtered items. So I want to tell React, OK, this is not a priority. It's OK for me if you display like list of items a little bit late, but the search input should be very responsive. User should be able to get immediate feedback as user types. So in order to defer that state update, I'm going to wrap the set filtered items inside start transition. So React will treat it as a low priority update. Now, if I try to run this, let me play this. And if you see, the input gets cleared immediately. The search results is not cleared yet. It will take a while. Yeah, now the search results got updated. Yeah, so you saw the immediate feedback you got from the input result, right? As user is typing, it's instantly responsive. You can also leverage like isPending flag, which is very useful to show the loading state. Because the filtered items transition was taking some time, so we can show a loader till the transition isn't pending. So if we try to run this and clear this, and you see the loader is appearing till the time it's rendering. So you can see like how we have improved the performance from before to here when we can, user is instantly getting the feedback. So this is the improvement actually. So before the example I showed you, it was 4,425 milliseconds time to, yeah, and then now it's like TBT is 105 milliseconds. If you notice the second picture, there are not many red blocks. So we have improved the performance by 42 times just by using a very small feature like start transition. There is, now everyone is happy, my boss is happy. So, but there is another hook as well, which lets us do the similar thing. It is called use deferred value. It does the same thing, but it's just a different way of implementing. So we will also see how we can use that. Let's take another example for it. So this is very similar example. It's also updating list of items. And if I'm clicking on the button, it should increment the count and update all the list of items incremented. So if I'm clicking, you can see how button is very slow. It's not updating the value. And the same problem is happening because multiple state updates and because of the heavier state update, it's taking a long time. Now I want to improve this using use deferred value. So let's see how we can do that. So the code for is very basic. So we just have a counter, which is initialized by 0. On the button click, we increment the value and display the list of items. So this is a item list, which is a long list. It goes through all the list of numbers and increment it based on the value. And now, in order to use useTransition, we first need to import use deferred value. And deferred value here is a value which is lagging behind. So if you click on the button, value gets updated instantly. But this deferred value does not get incremented instantly. So this is like debounce. So it is a value which will get updated when the main thread is free. OK, now React is free from, there's nothing more priority. So React will update this value. So this value is lagging behind. So the problem with this was happening because whenever we are incrementing, right? Whenever you click on the button, we increment, and then the item list component gets re-rendered because value is updated. So every time you click, there is change in the value. Item list gets updated, incrementing each of the value in the list. So first we need to do is we can pass deferred value so that the value does not change, right? So we have passed this value so that value gets updated, my counter gets updated, but at least my list of items should not get updated right away. But still, this will not solve the problem, because even if the deferred value is not getting updated instantly, but item list component will still get re-rendered with the same value. So how we can improve this is use memo. So using react.memo, we can make sure that this component re-renders only when the props are changed. So now we did two things, right? We first stopped passing the same value and told React that, OK, this can wait. And second thing is we also had to memoize it, because we know that React will always re-render if the parent state is updated. In order to not update it, we need to use react.memo so that the component only re-renders when there is a change in props, right? So when the deferred value gets changed, only then it will update it, which is at the end. So now we can also, in order to show the pending state, we can check if the deferred value is not equal to value, then the transition is still in pending, and we can show in the reduced opacity with the list. And now if we try to run this, you can see the button is really responsive. You improve the performance, you improve the UX, and the list is taking some time to get updated, but that is OK. So both useTransition and useDeferred value give us the same results. But useDeferred value is used when you don't have control over these state updates. Because sometimes you are working on a code which you cannot just go and wrap those states. Maybe you have a component which is coming from design system or something, and you don't have control over that. So in that cases, you can use useDeferred value. If you have access to the state, then it's better to use useTransition. Now, one thing to mention here is that both these APIs are very powerful APIs, but they come at a cost. So because React is doing an extra render for those state updates which were deferred, it creates a separate component tree, and then it renders later. So if you use it too much, it's not going to improve your performance, but makes it worse because of too many extra renders. So just use it wisely when you are using in your application. Next, I want to talk about is automatic batching. So we know that whenever there is a state update, React makes a re-render. Batching is when React groups those multiple state updates so that we can get some performance benefits. And automatic batching happens already in React out of the box. So let's say we have two states, which is count and is active, and we want to update those states on increment. So we updated set count and set is active. So both the state updates will be batched automatically and will happen there will be only single render for both the state updates. However, if I wrap it inside any asynchronous code, like set timeout, or inside fetch callback, so in that case, React does not batch it. So there will be two renders. But in React 18, everything is batched out of the box. So even if it is asynchronous, synchronous, all the state updates are batched out of the box. But sometimes you don't want some of the state updates to batch. So in that case, you can use flush sync method and wrap that particular state update that you don't want to batch inside flush sync. And then React will make sure to do an extra render for that state update. Next I want to talk about is suspense. How many of you have used suspense? Nice. And how many of you are at least familiar with it but have not used it? OK. Yeah, it's tricky. I try to use in my personal projects, and then I always used to mess up. But yeah, suspense basically is an old feature. It came in React 17, and it lets you specify the loading state. So if your component is not ready with suspense, you can display a fallback in a very syntactically easy way. So the main purpose for the suspense was to display fallback for lazy loaded component. For instance, if you have a profile component, and you are lazily loading the profile component, and you are returning profile. Now, if you want it's lazily loaded, so you do want to show a fallback till your component is not ready. So using suspense, you can simply wrap your profile inside suspense, and then in the fallback, you can show the beautiful loader. So this was one use case. Another popular use case for suspense is in data fetching. So let's take a component which fetches data. Here, I'm using pose. So in pose component, I'm fetching pose. Now make sure this fetch pose function you implement has to be compatible with suspense. So if you're using Next.js or Relay, you have already in the data fetching, suspense is supported out of the box. But if you're not using it, then you need to include some code which is compatible with the suspense so that the value which is returned is understood by the suspense. And here you can just return the post, and we can also wrap this post component inside suspense. Now, what suspense will do is that it will wait for both the components to render, and till then, it will show a loader. The main use case of suspense comes like when you have to control multiple loaders on the screen. For instance, like in this case, suspense is blocking the rendering of even profile, even if like it is ready, because maybe the post is not ready. So what we can do is that instead, we can wrap post in a separate suspense. So in that case, now you can still load profile, even if your post component is not ready. And when the post is ready, it will fall back to the nearest suspense block. So this was what suspense was like in React 17. It is mainly used for code splitting and only supported on client. But now in React 18, it's also supported with server-side rendering. Now, you must be like, what does this mean? But there are two things I mentioned here, right? Server-side rendering and suspense. So first, see what server-side rendering is. So it's basically server is sending a fully rendered page to the client. But this is a static page. It's not interactive. So server also sends a JS bundle. And what client does is that its favorite thing creates a DOM. Now, the next step is that this DOM, there will be attaching of events to the statically rendered page so that the page becomes interactive. And this is what we call hydration. So two things are happening here. Like we send HTML to the client, then events are attached on that HTML so that the page becomes interactive. And this is called like hydration. Now, where suspense comes in the picture is that let's say you have a page with like nav component, profile, and post. Now, your post component is a data fetching component. It fetches data for the post from the DB, wherever. So in order to send the page to the client, first server needs to download this page, and this can be slow if the post component is slow. So till the entire page is ready, server is not able to send the page to the client, right? So instead, what can be done here is that we can wrap this component in suspense and send the page with the loader. So we don't have to wait for the post component to load completely and simply send the page right away with the loader. So next step is hydration. Now page is sent to the server, and event binding will start instantly without waiting for the post component. So it will hydrate all the rest of the components, not just the post component. Now, when the post component is ready, it will be sent to the client in an extra bundle. So there will be a separate script tag call that will send the post component. And this component will be separately hydrated. So these are the two things like which are happening. So we are able to send the HTML without waiting for our data fetching component to fully load. So it's faster, of course, because we are sending the HTML right away. And we are able to hydrate as well separately, which makes sure that your components which are loaded are interactive instantly. So these were the changes which Suspense came up with. And next is the last section, which is, I think I covered it pretty fast. Yeah. So before you hit to the party, we talk about React Server Components. So this is an experimental feature, but it has been adopted by the frameworks. It's pretty much ready for the adoption. Next.js has already included this feature. So if you try with Next 13 or later versions, its server components are turned on by default. So in their app directory, it's all the components by default are server components. So traditionally, like React offers like multiple ways to render an application. One is like you render everything on the client. In client-side rendering, we only send like minimal HTML, and everything is like JS bundle. Then DOM will be created. Then from the JS bundle, React will create the DOM accordingly. In server-side rendering, everything is rendered on the server. We already talked about it. So we are sending the entire HTML fully rendered along with the JavaScript bundle to the client. Now, if you see in both these cases, like in server-side rendering, like the page was already there, but still React rebuilt the component tree, even if it was already available on the server. So now we have another strategy, which is called React Server Components. And in React Server Components, server sends a serialized object, which is already understood by the client. So it's not sending like full page. It's sending like an object. And this object is understood by the client, and it will create a DOM for it. So basically, this is how it looks. So if you pay attention to this, there are a couple of client files. So if you see emaillist.client, emailcard.client, so these are the files, and React is only sending the name, because these files will be in the bundle, and that will be rendered on the client. But if you notice the last part, and you see something like class name, like some JSX format, so this is a component which is rendered on the server. So server has already rendered it and sent it in like a string that, OK, this is rendered. So React instantly creates this without doing anything. Now, the server, the components which are rendered on the server, they don't have any interactivity. So we are kind of mixing the two things. The client components will have interactivity, and they will be fully rendered on the client. The server components will have no interactivity, and they will be rendered on the server. Now, why would you want to render things on the server? Is because all the components which are rendered on the server, they don't get added to the client bundle. We are just sending an HTML, like JSX-like format, a string to the client. So it doesn't come in the JS bundle at all. So 0 KB is added in the client bundle. And also, server is fast in computations. Like if you are using some like date library or data fetching even, like you don't have to make TCP connections. Like you can directly do those data fetching logic in server and handle like call your APIs directly. So that would be much faster rather than doing on the client. And also server, you get more security. So we get like multiple benefits out of using server components. There is one example which I created, and I can show you how this. OK. So this is the app which I built using server components. So if you notice the URL, OK. Yeah, so this part is important. So if I'm clicking on any card, you see the URL, it's loading another route. So we are changing the route, so it's coming from the server. And if I go to the network to show you how the payload looks. So this is exactly what I showed you, right? So we have 3 client files and 1 server file. And this is coming from the network request. So this is what React is sending. And one interesting thing is that if you change the state, like I have marked this as important, and now if I click on any other card, right? So it has loaded, changed the URL, the route has been reloaded, but the state has not changed. Like my client components, existing components are retaining the state. So this is something which is like also very interesting, that client components are retaining their state. Usually, like when you do it before React Server Components with like Next.js, you would only leverage the server-side rendering during the first load, right? After that, you won't be able to leverage server-side rendering. And you can create like basically multiple routes, but then the state of client components won't be maintained. The existing state will be lost. So this is a solution which server components provide to combine the best things of both. Server is good in computations, so do the computations on the server. Client is good for interactivity, then do the interactive part on the client. So now it's time for party. So that was about React 18, server components, suspense. And thank you for being here, staying till the end. And the slides, you can scan the QR code. There are the examples available, both the examples for the Next.js app as well as the examples which I used in the in this suspense, as well as for the use deferred value. You can find it on the GitHub. Thank you.